Hello learners, welcome to Dr. D.Y. Patil Vidyapith's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me Statistics and Quantitative Techniques. In this video, we are going to discuss Unit 3, that is Measures of Dispersion. So in this particular unit, we are going to discuss Introduction to the Measures of Dispersion, definition of dispersion. There are various measures of dispersion such as range, quartile deviation, mean deviation, standard deviation, variance, coefficient of variance, and then we will be discussing summary and references for this particular unit. Introduction to the measures of dispersion. So far we have looked at ways of summarizing data by showing some sort of average. So in previous unit we discussed measures of central tendency, and we know that a measure of central tendency gives us the bird's eye view of the entire data, and the measures of central tendency are called as averages. So measure of central tendency is a single value that can represent the entire data set, right, and they are called as averages. Measures of central tendency serve to locate the center of the distribution, but they do not reveal how the items are spread out on either side of the central value. So measures of central tendency gives us a central value of the numerical data, but they do not tell us how the data is spread away from that particular central value. So it is often useful to show how much these figures differ from the average. So it is very essential to understand also that how these values are spread away or spread out from the central value, and how all the values are differ from the central value, that is the averages. The measures of the scattering of items or measures of dispersion in a distribution about the average is called as dispersion. So how the data is spread away or spread out from the central value is dispersion. Measures of dispersion. The measures of dispersion are also called averages of the second order because they are based upon the deviations of the different values from the mean or other measures of the central tendency, which are called as averages of the first order. So we take deviations from the averages, right? So measures of central tendency are called as averages of the first order, and in case of measures of dispersion, we calculate the deviation. We calculate the averages of dispersion or average of deviations which are calculated about the first order averages, and that's why dispersion is called as, or the measures of dispersion are called as averages of second order. So in the words of Bowley, dispersion is the measure of variation of the item. According to Konar, dispersion is a measure of the extent to which the individual items vary from the central value. Purpose of measuring dispersion. A measure of dispersion appears to serve two purposes. There are two purposes. First one, it is one of the most important quantities used to characterize a frequency distribution. Second, it affords a basis for comparison between two and more frequency distribution. So dispersion is one of the most important quantities used to characterize a frequency distribution. And again, if we have to compare two or more data set, then again we need to understand the dispersion between these groups of data. The study of dispersion bears its importance from the fact that various distributions may have exactly the same averages. So we know that there can be distribution which will be having same averages, but they will be having different dispersion values. So that's why we need to study the dispersion, because we may be having group of data which may be having same averages, same mean values, but dispersion, that is how the values, individual items are spread away from the central value, is also essential to know in order to understand the difference between the various data sets. Measures of dispersion. So measures of dispersion are the descriptive statistics that describes how similar a set of scores are to each other. The more similar the scores to each other, the lower the measure of dispersion. So when the scores are similar to each other, the measure of dispersion is lower. The more similar scores are to each other, the lower the measure of dispersion. The less similar a score, if the data is spread away too much from the central value, then the measure of dispersion will be higher. In general, the most spread out distribution is the larger the measure of distribution. If the data is spread away too widely from the central value, then the measure of dispersion will be high. Otherwise, it will be low. There are various measures of variation or dispersion such as range, interquartile range, variance. So from variance we have population variance and sample variance. Then standard deviation are there, so we calculate standard deviation for population as well as standard deviation for sample. Standard deviation for the sample is denoted by S, and the population standard deviation is denoted by sigma. Population variance is denoted by sigma square, and the sample variance is denoted by S square. Then we can calculate coefficient of variation, which is based upon the standard deviation. Measures of dispersion. So these are the various measures of dispersion: range, interquartile range, semi-interquartile range, coefficient of quartile deviation, mean deviation, standard deviation, variance, and coefficient of variance. Range. So range is a basic and very simple measure of dispersion. It measures the variation in the data, and it is simply calculated by subtracting the smallest observation from the largest observation. So range is equal to largest observation minus smallest observation. Range ignores how the data are distributed. So we have two examples here, and the range value for both of these observations is same. So range is equal to 12 minus 5 for the first observation. So these are the values. This is the data set 7, 8, 9, 10, 11 and 12, and right. So the largest value is 12, the smallest value is 7, and this is equal to 5. So here the data spread is more widely, right, but still the data largest value is 12 and the smallest value is 7, and therefore in this case also range is 5. So it ignores how the data are distributed. It just takes only two values. It takes into account only two values, the largest value and the smallest value from the data set, in order to calculate range. Range is a measure. Okay, this is already discussed. The range is defined as the difference between the largest value and the smallest value. So we have an example here. What is the range of the following data? So 4, 8, 1, 6, 6, 2, 9, 3, 6, 9. These are the values. The largest values among these values is 9, and the smallest value is 1. So 9 minus 1, which is equal to 8, is the value of the range. When to use the range? The range is used when you have ordinal data, or you are presenting your results to people with little or no knowledge of statistics. So when we have ordinal data means the data which is arranged according to priority, right, according to rank, then this particular data is called as ordinal data. And when you are presenting your result to people who do not understand statistics, in that case you can use range as a measure of dispersion. Range is rarely used in scientific work as it is fairly insensitive. So it takes only two values to calculate the range, and therefore range is not based upon all the values. It is not capable of further mathematical treatment, and therefore it lacks scientific base. The range is rarely used in scientific work as it is insensitive. It depends on only two scores in the data set, the largest value and the smallest value. Two very different sets of data can have the same range. So when two different data sets are there, the spread is different, still we can get the same range value, because it is based upon the two values, largest value and the smallest value. Then there is something called as interquartile range. The interquartile range is the range of the middle half of the values. So it is a better measurement. It is a better measurement to use than the range, because it only refers to the middle half of the result. Basically the extreme are omitted and cannot affect the answer. So interquartile range means we take into account only the middle values, middle 50% values. of the observation, and we calculate range based upon this data. And the advantage of calculating interquartile range is that it doesn't take into consider the extreme values. Split order data into 4 quarters. So quartiles we are talking about now after range. Quartile deviation is another kind of measure of dispersion. So quartiles, so when we have data, we divide the entire data into 4 quarters, and this is again similar to the positional average like median. So when the data is divided into 4 quarters, this particular position will be the position of Q1, that is first quartile. Okay, let me point it out. So when we divide the data into 4 quarters, 1, 2, 3 and 4, the value at the interface of first and second quarter, that is this particular value, is the Q1 value. The value at the interface of second and third quartile is the Q2 value. This Q2 value divides the entire data into 2 equal halves, 50% of the data on the right hand side and 50% data on the left hand side, and that's why this Q2 is nothing but median. So these are the positional averages, quartiles. We are discussing dispersion, but we are going to calculate dispersion based upon these quartiles. So Q1 is the quartile which divides the data into two parts. In one part there will be 25% of the observation, and in the second part there will be 75% of the observation. Q2 divides the data into equal to halves, and Q3 divides the data into 2 parts, and on one side there will be 75% of the data, and on other side there will be 25% of the data. Position of the ith quartile is given by this particular formula, Qi. Qi is the ith quartile. So Qi is equal to I multiplied by n plus 1 divided by 4. So in case of first quartile, Q1 is equal to Q1, Q1 is equal to I will be equal to 1, n plus 1 divided by 4. This will be the position of the first quartile. Similarly, the position of the third quartile will be Q3. Q3 is equal to, this I will be equal to 3. So 3 multiplied by n plus 1 divided by 4. This will be the position of the third quartile, that is Q3. So data is ordered in array. So this is the data we have: 11, 12, 13, 16, 16, 17, 18, 21, 22. Now this particular data is already arranged in ascending order. So now first of all we will calculate Q1 and Q3 for these values. So this is ungrouped data. So position of Q1 is equal to 1. This is I value. We are using this particular formula. So Q1 is equal to, this I is equal to 1. Then n is the number of observation, 1, 2, 3, 4, 5, 6, and these are the 9 observations. So 1 multiplied by 9 plus 1 divided by 4. So this is 2.5. So the position of Q1 is 2.5. Now let us calculate. Okay, Q1 is already calculated. This is Q3. So Q3 is equal to 12 plus 13. Now this is Q1 only. So what we do? This is 2.5th observation. So this is the second observation. This is third observation, and Q1 will be the average of these two values. So 12 plus 13 divided by 2. So 12 plus 13 divided by 2 is 12.5. Similarly, we calculate Q3. How do we calculate Q3? Q3 is equal to 3 multiplied by, this I is equal to 3 in this case now, 3 multiplied by n plus 1, n is 9 plus 1 divided by 4. So 10 3s are 30, 30 divided by 4 is 7.5. Now 7.5 is the position of Q3. So 7.5th observation. So 1, 2, 3, 4, 5, 6 and 7. So this is the 7th observation. This is 8th observation. So 7.5th observation lies between 7th observation and 8th observation, and therefore Q3 will be equal to average of these two values, 7th and 8th value. So 18 plus 21 divided by 2. So 18 plus 20 is 38, plus 1 is 39 divided by 2. So this is equal to 19.5. So Q1 is 12.5 and Q3 is 19.5. So we make use of this Q3 and Q1 in order to calculate interquartile range. Interquartile range is equal to Q3 minus Q1. So 19.5 minus 12.5, so this is equal to 7. Interquartile range is equal to 7. To calculate the interquartile range, we must first find out the quartiles. Now we have understood how to calculate the quartiles. There are three quartiles called as Q1, Q2 and Q3. We do not need to worry about Q2. This is just a median. So Q2 is just a median. So this is not also required for the calculation. Q1 is simply the middle value of the bottom half of the data, and Q3 is the middle value of the top half of the data. So when we have data, like this is the entire data. So median is the value which, that is Q2 is equal to median. So Q2 or median is the value which divide the entire data into two equal halves. And what is said here, yes, Q1 is simply the middle value of the bottom half. So this is the first half, this is the second half. So Q1 is this value. This is the value which divide the first half into two equal halves again. So this is Q1 value, and Q3 is the value which divide the second half into two equal halves. This is Q3 value. So we calculate the interquartile range by using this particular formula, Q3 minus Q1, as we have done in this case. Here it is Q3 minus Q1, that is 19.5 minus 12.5, which is equal to 7. So remember, data must be placed in order. So we have this order data 10, 25, 45, 47, 49, 51. So this is the arranged data. The data is arranged according to the ascending rule. So what we do, we divide the entire data into two equal halves. Now this data is divided into two equal halves. Let me take the pointer. So this data is divided into two equal halves. Now this data set consists of how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 numbers on the left hand side of this Q2 or median, and 9 numbers on the right hand side. Right. Now again we divide this entire data set, this first half into two equal halves and second half into two equal halves. So this will give us the Q1 value, and this will give us the Q3 value. Right. So first of all, we divided the entire data into two equal halves. This particular part will give us Q2. Now as the number of observations in this particular data set consist of 18 observations, total number of 18 observations. So the Q2 or median will be the average of middle two values. Right. So this is Q2 value. Now when we have to further divide the two halves which are made by the quartile 2, we have odd number of observations here. So by keeping 4 observations on the left hand side and 4 observations on the right hand side, we can get the Q1 value, which is 49, and same thing can be done with the second part. So Q3 is 62, and interquartile range will be equal to Q3 minus Q1. So 62 minus 49, this is equal to 13. Quartile deviation. So we learn how to calculate the quartiles and interquartile range. Quartile deviation is the second measure of dispersion after range. Quartiles are not measures of dispersion. Quartiles are required for the calculation of quartile deviation. So it is the second measure of dispersion, no doubt improved version over the range. So it is the improved version over the range. It is based upon the quartiles. So calculating this may require upper quartile and lower quartiles. So calculation of deviation will require Q3 and Q1, and then it is divided by 2. So hence it is the half of the difference between two quartiles. It is also a semi-interquartile range. So quartile deviation is equal to Q3 minus Q1 divided by 2. So interquartile range divided by 2 is the quartile deviation. So semi-interquartile range or quartile deviation is defined as the difference of the first and the third quartile divided by 2. So first quartile is the 25th percentile, because there are 25% of the observation have value less than Q1. I am talking about Q1. Okay. So let me draw it again. So suppose this is the entire data set. Right. This is Q2, that is median, and this is Q1. And this is Q3. Right. So there are 25% of the observation here, 25 here, 25% here, and 25% here. So Q1 is the positional average, we can say, and there are 25% of the observation having value less than Q1, and there will be 75% of the observation which have value greater than Q1. That's why Q1 is called as 25th percentile. The third quartile, that is Q3, right, is called as 75th percentile because there are 75% of the observation having value less than Q3, and there are only 25% observation which have value greater than Q3, and that's why it is called as 75th percentile, and Q2 is called as 50th percentile. So semi interquartile range SIR is equal to Q3 minus Q1 divided by 2. Then there is something called as coefficient of quartile deviation, the relative measure of dispersion. This particular semi interquartile range or the quartile deviation is not a relative measure. Why it is not a relative measure? Because the values are not so consistent, so we cannot compare the two group of data by using the quartile deviation or semi interquartile range. What we need to calculate coefficient of quartile deviation, because the value of coefficient of quartile deviation always lies between 0 and 1, and that's why by knowing the value of coefficient of quartile deviation we can compare the different data set. The relative measure of dispersion corresponding to quartile deviation is known as coefficient of quartile deviation. It is calculated by using this formula. Quartile deviation is equal to Q3 minus Q1 divided by Q3 plus Q1. So the value of this particular coefficient is always between 0 and 1, and that's why it helps us to compare two different data set. Then there is mean deviation. Mean deviation is also known as average deviation. In this case, deviation taken from any average, especially mean, median or mode. While taking deviation, we have to ignore negative items and consider all them as positive. So we take mode values. The formula is given below. So mean deviation about mean is given by summation of x minus x bar. So these deviations are calculated about x bar. We take modal values. Modal values means the positive values only. Even if they are negative, we convert them into positive. So summation of deviations divided by n is the number of observations. So this is how we calculate the mean deviation about mean. Now in case of mean deviation about median, we calculate deviations of individual x values about median values. So summation of d divided by n. Similarly, we can calculate mean deviation for the about mode also. So in that case, we will be calculating deviation about the mode value. Standard deviation. The concept of standard deviation was first introduced by Carl Pearson in 1893. The standard deviation is the most useful and most popular measure of dispersion, just as arithmetic mean. So we know that arithmetic mean is the most popular measure of central tendency. Similar to that, we have standard deviation, which is the most popular measure of dispersion. So the standard deviation is the best of all the measures of dispersion. Standard deviation is represented by the Greek letter sigma. So standard deviation of population is denoted by sigma, and that of sample is denoted by s. It is always calculated from the arithmetic mean. So the calculation of standard deviation is based upon the calculation of arithmetic mean. Median and mode are not considered. While looking at earlier measures of dispersion, all of them suffer from one or the other demerit. So we have seen range, interquartile range, quartile deviation, then mean deviation, and all of these measures of dispersion suffer from one or the other demerit. So range suffer from a serious drawback as it considers only two values for the calculation, and quartile deviation considers only 50% of the data and ignores other 50% of the data. Mean deviation, no doubt an improved measure of dispersion, but ignores negative signs without any basis, and therefore all these measures of dispersion like quartile deviation, range and mean deviation lacks scientific base, as well as they have some demerits. So Carl Pearson, after observing all these things, has given us a more scientific formula for calculating the dispersion. So while calculating dispersion, that is standard deviation, we take deviations of individual observations from their arithmetic mean and then each squares. Then we calculate squares of these deviation, and the sum of squares is divided by the number of observations. The square root of this sum is known as standard deviation. So basically standard deviation is square root of sum of all the square deviations divided by n, or it is equal to square root of average of all squared deviation in simple terms. So the standard deviation can be calculated by using this particular formula. We have population standard deviation on the right hand side, which is denoted by sigma. Sigma is equal to root of summation of xi minus mu square divided by n, and on the left hand side we have s is equal to summation of xi minus x bar bracket square divided by n minus 1. So here we must consider a few things. So this is sample standard deviation, this is x bar is sample mean, so xi minus x bar, this is the deviation, squares of this deviation, addition of this deviation divided by here n minus 1, where n minus 1 is the degrees of freedom. And in case of population standard deviation, we have sigma. Sigma is equal to summation of xi minus mu. Now this mu is nothing but the arithmetic mean of the population. Xi are the individual values in the population. This is the deviation xi minus mu, square deviation, addition of all the deviation divided by n. So we get average of deviation and then we find out root of it. So let us calculate standard deviation from a frequency distribution. What is the formula? So approximating the standard deviation, so used when the raw data are not available and the only source of data is the frequency distribution, we have to use this particular formula. S is equal to summation of xi minus x bar bracket square, this is multiplied by f, this is divided by n. So instead of this mj you can use xi, that is individual values in the sample. Comparing standard deviation, so we have three data sets here, data A, data B and data C. Now look at this observation. There are, in this particular data set, there is only one value 11, there is only one 12, there is only one 13, 16 appears twice, 17 appears only once, 18 appears only once, 21 appears only once. So how many values are there? 1, 2, 3, 4, 5, 6, 7 and 8 numbers are there. So mean is equal to 15.5. So when you calculate the mean of all these values, 11 plus 12 plus 13 plus 16 plus 16 plus 17 plus 18 plus 21 divided by 8, we get this mean 15.5, and the standard deviation is calculated to be 3.338. Now second data set consists of values. There is only one 14, there are three 15s, 16 appears 3 number of times, 17 appears only once in this particular data set. There are 8 observations again. The mean is again same, mean is equal to 15.5, but the standard deviation is equal to 0.9258. Again look at the data set C. Here the 11 appears 3 times, 12 appears only once, 19 appears once and 20 appears 3 times. Mean is again 15.5 and the standard deviation is 4.57. So what we learn from this is that even if the arithmetic mean is equal for the three data set, the standard deviation is different, and when the spread of the data is not so high, or the spread is not so much, in that case the standard deviation value will be lower, and where the spread is very high like this, in case of data A and data C, the spread is very high, and that's why the standard deviation is higher. Merits of standard deviation. So very popular scientific measure of dispersion. From standard deviation we can calculate skewness, correlation. It considers all the items in the series, and squaring of deviation make them positive, and the difficulty about algebraic signs which was expressed in case of mean deviation is not found here. Demerits of standard deviation. So calculation is difficult, not as easier as range and quartile deviation. It always depends upon the arithmetic mean. It cannot be calculated for qualitative data. Standard deviation is one of the most important measure of dispersion. It is much more accurate than the interquartile range. It takes into account all the values and is not unduly affected by extreme values. So what does it measure? Standard deviation, it measures the dispersion or spread of data around the mean. A large number of standard deviation means there is wide spread of values around the mean, whereas a small number of standard deviation implies that the values are grouped close together and they are not spread out too much. Standard deviation, these are the formulae which we have already discussed. Standard deviation is square root of variance. Standard deviation for group data, so in case of group data, in case of frequency distribution, we have to multiply the squared deviation by frequencies, then we divide it by n. So find the standard deviation for the minimum temperatures of 10 weather stations in Britain on winter's day. So let us calculate standard deviation, mean deviation and other measures of dispersion in the next part of the video. So we have understood the theoretical background of all the measures of dispersion. We have understood what is range, we have understood what is quartile, interquartile range, what is quartile deviation, what is mean deviation, what is standard deviation. We have understood what are the merits and demerits of various measures of dispersion. So standard deviation, find the standard deviation of the minimum temperatures of 10 weather stations in Britain on winter's day. So these are the temperatures of 10 different weather stations in Britain in winter season. So 5 degree, 9 degrees centigrade, 3 degrees centigrade, 2, 7, 9. So these are individual data set. This is ungrouped data, and for this data we have to calculate the standard deviation. So this is how you have to form a table. How do we have? Why do we have to form this table? Because first of all we need to write down the formula. So let me write down the formula for standard deviation. Standard deviation denoted by sigma. Sigma is equal to summation of square deviation, right? Xi minus x bar. These are the square deviation. Summation of this square deviation divided by n. N is the number of observation, and then root of this. Now look at this formula. We need xi. Xi values are already given there. We need x bar value. So x bar is the arithmetic mean, and then we need n, that is number of observation. So all these values are needed in order to calculate the standard deviation, and that's why we need to form a table. So these are the values, individual values given in order to calculate the temperature, the standard deviation. So this is how we have to form a table. So all xi values will be mentioned here in the first column, right? Then we will be calculating summation of x from the first column, and we can calculate x bar, that is arithmetic mean, from the first column. Then we can write the arithmetic mean in the second column. In the third column we will be calculating deviation, and in the fourth column squared deviations. So these are the individual values given here. Let me take the pointer. These are the values of temperature of 10 different weather stations in Britain in winter season. So these are the 10 values: 5, 9, 3, 2, 7, 9, 8, 2, 2 and 3. So from this we can calculate. Now again let me write the formula for standard deviation, which is equal to root of average of squared deviation. So this is the formula. So we have x values here. We need x bar value. Look at this formula. We need deviation, but for calculation of deviation we need x bar value, and x bar is equal to, here it is, x bar is equal to summation of x divided by n. So these are individual values, addition of these values divided by n. So in the next slide we have addition of all these values equal to 50, and x bar is equal to summation of x divided by n. So 50 divided by 10 is equal to 5. So let me write down that formula again. Sigma is equal to root of average of squared deviation, right? So we calculated x bar now here. Summation of x was 50 and x bar is equal to 50. Now from this we can write down all these x bar values here, like 5, 5, 5, 5, 10 times, right? So this is how we can write down x bar values in the second column. In the third column we will be calculating deviation. So 5 minus 5 is 0, 9 minus 5 is 4, and so on. So here the values of mean are written in the second column. In the third column we have to write down the deviation, that is 5 minus 5 is 0, 9 minus 5 is 4, 3 minus 5 is minus 2, and so on. Let me write down the formula again. Sigma is equal to root of summation of xi minus x bar bracket square divided by n. So once we calculate deviation, what we need squares of deviation. So in the fourth column we calculate squares of deviation. So 0 square is 0, 4 square is 16, minus 2 square is 4, minus 3 square is 9, and so on. So these are the square deviation. Alright, so once we calculate squares of deviation, what we have to do, we have to find out the addition of squares. Again, let me write down the formula. Sigma is equal to root of summation of xi minus x bar square divided by n. So once we calculate all the deviation, we have to find out summation, that is sigma x minus x bar bracket square. So addition of all these deviations will be, square deviations will be written here. Then we find out average of square deviation, that is summation of squared deviation divided by n, that will be here. And then we find out root, that is the final value of standard deviation. So this is equal to 80. Summation of xi minus x bar bracket square, this is equal to 80. Then summation of xi minus x bar bracket square divided by n. How many data values are there? 10. So 80 divided by 10 will be equal to 8. Here it is. Then summation of xi minus x bar bracket square divided by n and root of it. So root of 8 will be equal to the standard deviation, the required standard deviation, which is 2.8. So root of 8 is equal to 2.8, which is the value of the standard deviation of this data. So this is how we calculate standard deviation for individual data. Why standard deviation is much more useful? So why do we calculate standard deviation? Because it is much more useful. It is based upon all the observation. It is based upon arithmetic mean, and therefore it is one of the important measure of dispersion. For example, our 2.8 means that there is a 68% chance of the temperature falling within 2.8 degree Celsius range of the temperature of 5 degrees Celsius. So 5 degrees Celsius is the mean. Okay, let me write down here. So why the standard deviation is so important? Because it is based upon all the observation. It uses the mean, arithmetic mean also. Now this 5 degrees Celsius is the arithmetic mean, right? The central value, and 2.8 is the standard deviation. When we calculate this, x bar, that is arithmetic mean, plus minus 1 sigma, that is 1 standard deviation, 68% chance of the temperature falling within this range. So there is a 68% of chance, or 68% of the observation will fall in this particular range. This is sigma, not 6. So x bar plus minus 1 sigma, that is x bar is 5 degree plus minus 2.8. So within this range means this is 2.2 to 7.8 degrees Celsius. So in this range there will be 68% of the, there is a chance that 68% of the times the temperature will fall in this particular range. So that is 1 standard deviation away from the mean. Normally values are said to lie between 1 to 3 standard deviations from the mean. So if the values are 1 standard deviation away from the mean, there is a 68% of the chance that value will lie in this particular range, x bar plus minus 1 sigma. When we take 2 sigma, that is if x bar plus minus 2 sigma, so x bar is 5 in this case, so 5 plus minus 2 multiplied by 2.8. So this will give us a bigger range. So 2 multiplied by 2.8 is 5.6. So 5.6, so 5 minus 5.6, so 5 minus 5.6 will be 0.56 minus, and 5 plus 5.6 will be 10.56. So in this range from minus 0.56 to 10.56 degrees Celsius. there will be 95% of the observation, 95.45% of the observation. There is a chance that 95.45% of the observation will lie this range of x bar plus minus 2 sigma. And if we consider this range x bar plus minus 3 sigma, 99.97% of the observation will be in this particular range. So this is the significance of standard deviation. So where did the 68% stand? So if we have this x bar plus minus 1 sigma, it will accommodate 68% of the data. And when we take x bar plus minus 1 sigma, this particular range will accommodate 95% of the data. And when we take x bar plus minus 3 sigma, this will accommodate 99.97% of the data. So this is a normal distribution curve. It is a bell-shaped curve with the most of the data cluster around the mean value, and where the data gradually declines the further you get from the mean until very few data appears at the extreme. So for example, people's height. So people's height is something very a natural variable, and all the natural variables observe normal distribution, they are normally distributed. So most people are near to average. So most of the people will be having height near to 6 feet, and there will be very few people who will be having height less than 3 feet, or will be having height more than 7 or 8 feet, right? So that's why the tails are shorter and they are approaching to the x-axis, and the central part is very high. So this is the bell-shaped diagram, normal distribution diagram. So there are very few are there at the end, at the tail of the this particular diagram. So this is 68% of the chance that there is if we take the deviation 1 sigma standard deviation from the mean, so 68% of the observation will fall in this particular range. So 68% of the values lie within a range of plus minus 1 standard deviation from the mean. 95% of the observation lie within the range of plus minus 2 standard deviation from the mean, and 99.97% of the values lie between the range x bar plus minus 3 sigma. If you look at the graph, you can see the most of the data, 68%, is located within 1 standard deviation on either side of the mean. Even more, 95% is located within two standard deviation on either side of the mean, and 99% of the data is located within 3 standard deviation on either side of the mean. So now we are going to calculate standard deviation for ungrouped data. So family is mentioned here and the size is mentioned below. So this is again ungrouped data, we can directly calculate it. So family number is given here. These are x values, xi values. So xi is the size of the family. So 3 members are in the family 1, 3 members are there in the family 2, 4 members are there in the family 3, and so on. So these are x values. This is again individual data. This is not the group data. So these are xi values. Then we calculate. Here the formula is written. X bar we calculate here, and the standard deviation formula is written here. Now this is a sample, and that's why we have mentioned here s square and n minus degrees of freedom we have taken. So xi, these are individual values. We calculate deviation. So for calculation of deviation we require x bar, that is arithmetic mean. So this is x bar. So x bar is calculated here. X bar is equal to summation of x divided by n. So addition of all these values is equal to 50. So 50 divided by 10 is 5, right? Then we got x bar values. Now we can calculate deviation. Deviation is the difference between individual values minus the x bar value. So 3 minus 5 is minus 2, 3 minus 5 is minus 2, 4 minus 5 is minus 1, 4 minus 5 is minus 1, 5 minus 5 is 0, 5 minus 5 is 0, 6 minus 5 is 0, and so on. So we got deviations. Addition of deviation is always equal to 0 when it is calculated about arithmetic mean. Then we calculate squared deviation. So minus 2 square is 4, minus 2 square is 4, minus 1 square is 1, minus 1 square is 1, 0 square is 0, 0 square is 0, 1, 1, 1, 1, 2 square is 4, 2 square is 4. Addition of all these squared deviation is equal to 20. Then addition of all this square deviation is equal to 20. Now we will calculate this. standard deviation or S is equal to root of this summation of xi minus x bar bracket square divided by n minus 1. So summation of xi minus x bar is 20 divided by n minus 1. So there are 10 number of observations, but we subtract 1 from it as a degrees of freedom. So root of this, so root of 20 upon 9 is equal to 1.48. So this is the standard deviation, and the squared standard deviation is equal to 20 upon 9, which is called as variance. So square of standard deviation, so variance is equal to S square. Standard deviation is S and variance is S square. So 20 upon 9, and this is equal to 2.2. So variance is 2.2 and the standard deviation is a root of variance, which is equal to 1.48. Find the standard deviation for group data. Now this is a group data, 3, 5, 7, 8, 9, 2, 3, 2. Okay, these are the values, and we have to calculate the group. We have to calculate the standard deviation for this group data. So these are x values. Let me write here. Column headings are missing. These are x values. These are frequency values. Then what do we need? Apex. Then after apex, we calculate x minus x bar. Let us do it. So these are x values, these are apex values, these are f values, these are x values. Apex values are given here. So 3 2s are 6, 5 3s are 15, 7 2s are 14, 8 2s are 16, 9 1s are 9. So we got all apex values. From this we can calculate the arithmetic mean. So x bar is equal to summation of apex divided by summation of f. This is arithmetic mean for group data. So summation of apex is 60, here it is, divided by 10 number of observations, 1 2 3 4 5. Okay, summation of f is number of observations, so 2 plus 3 plus 2 plus 2 plus 1, so this is equal to 10. So 60 divided by 10 is 6 is the arithmetic mean. Now what we have to do, we will be taking deviations of individual values about the arithmetic mean. So 3 minus 6 will be minus 3. So this is deviation, x minus x bar. 5 minus 6 will be minus 1, then 7 minus 6 will be 1, this 8 minus 6 will be 2, and 9 minus 6 will be 3. So we calculated deviation. Then look at the formula. What do we need? Squares of these deviations. So these are the squares of this deviation, xi minus x bar bracket square. So minus 3 square is 9, minus 1 square is 1, 1 square is 1, 2 square is 4, 3 square is 9. So this is how we calculated square deviation. Once we calculate square deviation, what we do? Look at the formula, this particular formula. Square deviations are multiplied by frequency. So these are the square deviation. We have to multiply the square deviations by frequency. So 9 multiplied by this 2 is equal to 18. Then 1, this is square deviation, multiplied by frequency 3, this is equal to 3. Then 1 multiplied by 2 is 2, and so on. So we calculated frequency multiplied by squared deviations. Frequency multiplied by squared deviation, and the addition is given as this, summation of frequency multiplied by squared deviations. So this is equal to 40. Now we can put all these values in this equation. So summation of f multiplied by squared deviation, this is equal to 40, and n minus 1. As this is again a sample, we have to take degrees of freedom n minus 1. So there are 10 observations. So instead of that, we are writing n minus 1, that is 9. So 40 divided by 9, this is equal to 4.44. So 4.44 is the standard deviation for this grouped data or the frequency data. Variance is defined as the average of the square deviation or square of standard deviation of set of observation. So variance defined average of square deviation. So these are the square deviation. Numerator is the square deviation divided by n. N is the number of observation. So average of square deviation is variance, and when we calculate sigma and when we square the standard deviation, we get the variance. So variance is the square of standard deviation. What does the variance formula mean? So variance is the mean of standard deviation, mean of the squared standard deviations. The larger the variance is, the more the scores deviate on average away from the mean. So when we get the larger value of the variance, the values, individual values in a data set are spread away more. Then when the variance value is smaller, the less is the variance, or less is the spread of the values about the average. Variance, important measure of variation, shows variation about the mean or sample variance. So sample variance is given by S square and the population variance is given by sigma square. So we have already learned the formulae for standard deviation. The formula for standard deviation will be equal to this, right, and square of this will be equal to S square, like this. So formula for population standard deviation will be this, and once we remove this, it will be sigma square. Coefficient of variation. Now coefficient of variation is again one of the important measure of dispersion, and it is very handy tool for measuring the consistency or the spread in two different data set. So the coefficient of variation indicates the spread of values around the mean by percentage. So it is a relative measure again, right? So we divide the standard deviation of a data set divide by its mean, and then we multiply it by 100. So this is how we calculate coefficient of variation. We can calculate coefficient of variation for different data set, and by comparing the coefficient of variation of different data set, we can judge which data set is more consistent. So coefficient of variation, measure of relative variation. It is a measure of relative variation, and every relative measure help us to compare the data, always in percentage. So it is calculated in percentage as we multiply the fraction by 100. Show variation relative to mean. So we calculate standard deviation by, we use standard deviation as well as mean, and it is basically a ratio of standard deviation to the mean. So it is a relative measure used to compare two or more data set measured in different units, and it is sensitive to outliers. Comparing coefficient of variation, we have stock A and stock B. The average price of stock A last year was $50 and the standard deviation was $2. We have stock B, and the average price for stock B in the last year was $100, and the standard deviation of stock B was standard deviation of prices of stock B is $5. So we have to calculate the coefficient of variation. Okay, so we'll do it here. Yes, so let us calculate CV for stock A, where we are interested to know which stock is better, which stock is less volatile, right? Volatile is the word we use for the variation in the stock, right? So more is the variation, more is the volatility, and more is the risk. So coefficient of variation of stock A here. So how do we calculate it? Sigma of stock A divided by mean of stock A, that is x bar of A, and this is multiplied by 100. Then CV of stock B, this is equal to standard deviation of stock B divided by x bar of stock B multiplied by 100. So now we are going to judge which stock is more volatile, more risky. So average price, okay, average is 50 and 2 divided by 50. So this is 2 divided by 50 multiplied by 100. This is equal to 4. 52s are 100. So this is equal to 4. Then we have for stock B, the average price is 100. So sigma is 5. This is 100 multiplied by 100. So 100 gets cancelled, and this is equal to 5. So which stock is more consistent and less volatile? So coefficient of variation of stock B is 5 and that of stock A is 4. So less is the coefficient of variation, less is the volatility, less is the risk, less is the spread, and therefore the stock prices of stock A are less volatile, less spread than the stock prices of stock B, and therefore stock A is less risky as compared to the stock B. Things you need to know: the higher the coefficient of variation, the more widely spread the values are around the mean. So higher the coefficient of variation, the values are spread away more widely. The purpose of coefficient of variation is to let us compare the spread of values between different data set. So one of the basic purpose of coefficient of variation is that it helps us to compare the spread of values between different data sets. So one more example, we have comments on children in a community. So we have height and weight, these two parameters. The mean height is 40 inch, the mean weight is 10 kg, the standard deviation is 5 inch, standard deviation of height is 5 inch, and standard deviation of weight is 2 kg. Coefficient of variation is given here 0.125. Even if it wasn't given, we would have calculated it. So like 5 divided by 40 multiplied by 100, this is 0.125, and this is 0.20. Right, now this is not calculated in percentage because these are fraction values only. Okay, now we have to compare whether height is more consistent or weight is more consistent. Now the coefficient of variation for height is 0.125 and that for weight is 0.20. So CV for height is less and CV for weight is more. So we can say that height is more consistent and height is less widely spread and weight is more widely spread, and therefore since the coefficient of variation for weight is greater than that of height, we would tend to conclude that weight has more variability. So weight has more variability because it has higher coefficient of variation than height in the population. So this is how we can use the coefficient of variation to compare two different data sets. Summary: the measures of variation are useful for further treatment of data collected during the study. The study of measures of dispersion can serve as the foundation for comparison between two or more frequency distributions. Standard deviation or variance is never negative. Standard deviation cannot be negative, variance cannot be negative. When all the observations are equal, standard deviation is equal to 0. So when there is no spread in the data, when all the observations are same or equal, then there will not be any spread or dispersion, and therefore the standard deviation will be equal to 0. When all the observations in a data set are increased or decreased by constant, standard deviation doesn't change, it remains constant as against the value of mean. So this is all about measures of dispersion. We have learned how to calculate various measures of dispersion and their importance. So thank you so much for watching this video.